Hi students and family members, this is Mr. Panza. Today's focus question is at the top of this page. How do we use concrete objects to help us multiply? Today we will be using base 10 blocks and the concrete model part of the CRA representation. Concrete is the first way that you can start to understand concepts in mathematics. Today, multiplication. The example we'll look at is 25 times 13. What I've done here is I've taken my base 10 blocks and I've represented 25 times 13. Let me show you how. 25 we know has 2 in the tens place value, so I represent that with one group of 10 and a second group of 10. It also has a 5 in the ones, so I've taken 1, 2, 3, 4, 5 individual unit cubes to represent my total of 25. My other factor is 13. So I've placed that at the top of your screen here by showing one group of 10, because there is one group of 10 in the number 13, and 3 groups of one individual unit cubes. So 10 plus 3 is 13, and 10 plus 10 plus 5 is 25. That's expanded form. Those are my two factors in what I'm multiplying today. Now, if I didn't know how to do the traditional method of multiplication, one of the best ways to learn what multiplication is actually doing is by using concrete objects like base 10 blocks. So I'm going to take those factors and I'm going to separate them out with these little sticks here. These blue sticks then are going to call to mind that the numbers on the outside are actually my factors. And now the area right here is what I'm going to fill when I multiply each piece by each piece. Let me show you what I'm talking about. In multiplication, you take step-by-steps in place value to multiply, which we'll get to once we get to the actual numbers. But using base 10 blocks, it's more visual and you can see what we're doing. For example, we take this group of 10 and multiply it by 10. And when you multiply a group of 10 by 10, you get 100. So I'm going to fill my surface area with a block of 100. And then I'm going to take this 10 and multiply it by 1. And 10 times 1 is 10, a group of 10. I'm going to do 10 times 1, which is a second group of 10. And then I'm going to do 10 times 1, which is a third group of 10. Then I move right on down in my equation, and I'm going to take this group of 10 and multiply it by this group of 10 on the outside of my blue lines here. And remember, 10 times 10 is 100. And I continue to multiply the rest. 10 times 1 is a group of 10. 10 times 1 is 10. And 10 times 1 is 10. I'm ready to multiply my ones. 1 times 1 is 1. 1 times 1 is 1. 1 times 1 is 1. I do that 4 more times, because I have a group of 5 ones here. 1 times 1 is 1. 1 times 1 is 1. 1 times 1 is 1. And I continue. 1 times 1 is 1. 1 times 1 is 1. And 1 times 1 is 1. 1 times 1 1. 1 times 1 is 1. 1 times 1 is 1. Let's just make sure I remember. I always say, spelling doesn't count in math, but neatness definitely does. And if I were to leave those blocks the way that they were, I would maybe have thought that I was finished, when in reality, I wasn't. I still have one more row to do, which is 1 times 1, which is 1. 1 times 1, which is 1, and 1 times 1, which is 1. Then I can multiply 1 times 10, which is 10, and 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 one more time, 1 times 10, is 10. So you can see when I multiply this factor of 25 times this factor of 13, I filled this surface area with my base 10 blocks. Now I need to combine all of the base 10 blocks to see how many hundreds I have, how many tens I have, and how many ones I have. Let's take a look. So as you can see, I've taken all of my base 10 blocks that were in my product, or the answer to the multiplication problem, and I've outlined them here on a makeshift place value chart. How many hundreds do I have? I have 2 100 blocks. How many tens do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 tens. And how many ones do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 ones. So I have 2 100s, I have 11 tens, and I have 15 ones. Remember, however, in a base 10 block, we can exchange, which is what we're going to do when we see a group of 10 tens or a group of 10 ones. So I'm going to take this group of 10 tens and put it over here in to the 100s. And I'm going to take this group of 10 ones and exchange it, piece them all together, and put it into my tens. And now I have 5 in my ones. So when I go back to my original problem, and I eventually multiply this the traditional way, 5 times 3 is 15. 3 times 2 is 6, plus 1 is 7. Now I'm multiplying the tens, so this 0 has to be set for a place value holder. 1 times 5 is 5. 1 times 2 is 2. And I add those two partial products. I have 5 in my ones, which is what we show right here. And I have a 2 in my tens and a 3 in my hundreds. So 3 100 blocks, 2 10 blocks, and 5 1 blocks. So 25 times 13 is equal to 325. And what we did was showed you concrete representation with the base 10 blocks. Did you know you could also do that with division? Let's shift our focus to division. Main question, how do we use objects, concrete objects like base 10 blocks, as you see below, to divide? The division example. 56 is my dividend, 3 is my divisor. So 56 divided by 3. First of all, we're looking for the quotient, or the answer, or what is in each group. And the total number of groups is 3. So here's how I represent 56, my dividend. I have 5 groups of 10 over here, and 6 ones right here. And I want to separate those into 3 groups. So right here are my 3 groups. I've now used what we were using for multiplication in a different way. I've separated 1 group, 2 groups, 3 groups. And I want to equally divide these into groups. So the only way I can do that with my 5 is by taking 1, because only 1 group of 10 will fit in equally to each of these 3 groups, which leaves me with 2 groups of 10 and 6 ones. So I'm going to break these apart and regroup them. As you can see up here, there's my 2 groups of 10 and my 6 ones. And I'm once again going to put them equally into the groups down below. Let me move these so you can see them better. So now you can see I first divided 3 into the 5, and I've got 1 in each category. So how many can I fit into each of those groups? Just 1, because 3 times 1 is 3. My current remaining is 2, or 26 tens, 2 10s, and 6 ones, as was represented by these base 10 blocks. Now I'm going to see how many groups I can fit in, or how many I can fit into these 3 groups. Here's my first 3, second 3, And third group of 3. Remember, it's equal. You want everything to be equal. I'm noticing now you can't see that first group of 3. Let me pull that over so you can see it and continue dividing these equally. Second group of 3 into each of these areas. Third group of 3. Well, that's not going to work. I only have 2 here. So if you're like me and you guessed wrong and you see that we're 1 short here, that's not equal. So if 3 was too many, let's take it back and try 2. So I'm back with my original 26, which again is coming from the original division. I have 26 in my 1, so I need to divide that equally into the 3 groups. This time I'm going to try 2 at a time. There's my first group of 2, second group of 2, third group of 2. Now I have 3. So I have 4 groups, 4 groups, and 4 groups, and 2 left over, which means when I look at one group, I've got 1, 10, and 1, 2, 3, 4, 5, 6, 7, 8 ones. So my ones, I get an 8, because 8 times 3 is 24, and when I subtract, I have 2, which is my remainder, which is left over. So what is the number that I can fit in each of these 3 groups? 18, because 10 plus 8 ones is 18, with a remainder of 2, or 2 left over. And that's how you can use concrete objects to divide as well as to multiply.